Hello. Today I'm doing a video on heating processes. Heating process. So here I have two questions, and the first one says you want to make a cool drink from some 19.7 degrees tap water by adding ice. Calculate the mass of the ice at negative 11.3 degrees Celsius. You need to cool 195 grams of such tap water in a 215 grams glass to a temperature of 3.6 degrees Celsius. Neglect any heat that your drink would gain from its surroundings. Okay, so first let's list the things, right? So basically, we have a cool drink, which is just tap water. Okay, so water first, right? And then there's glass, and there's I don't know, like ice I'm adding, right? So the mass. Oh, I do. Not that this is not needed, but it's better for when I'm doing the question. So the mass of the water is there's 195 grams of such tap water. So 0.1 kilograms, and in the glass there is 0.215 grams of glass, and then the ice is just m as we want to find it out, right? And so the water at the very start is 19.7 degrees Celsius, and we assume the glass is this as well, and they both want to go to 3.6 degrees Celsius, and the ice is at negative 11.3 degrees Celsius. Let's want to go to 0 degrees Celsius first, and 0 degrees Celsius to 3.6 degrees Celsius. There will be a state change. So first, let's do the ice part, right? Because that's important. Okay, so let's see. Okay, actually, we want the specific um heat capacity for each of these, right? So first, we know that water is 4180, well, joules per kilogram per degree Celsius. Glass we don't know, so I searched it up, and it is 840, and ice is 2100, and latent heat of ice is 3.33 times 10 to the power 5. Now we can start doing it. The ice side, we first have Q equals ml, and Q equals mc delta T. So first we'll do the ice side, so basically that's m times 3.3. We'll do the other side. 3.33 times 10 to the power 5 m plus, well, the after it melted. Actually, no, this happens after we melt it first. Right, so that's what happens when we are melting it. So before that, we want to make the ice at 0 degrees. So basically, we just do mass times 2100 times 0 times 0 minus negative 11.3, and this will also have to add the water that the ice becomes to 3.6. So m times 4180, as that's water now, times 3.6 take 0. And this all equal to the actual tap water inside the drink. So which is what's the thing again? 0.195 times 4180 times 19.7, take 3.6, and then we have to plus the glass 0.215 times times what's glass again? 840 times the same wait, yeah, yes, 19.7, take 3.6. Let's simplify that. Sm is the common, like a common thing inside these equations. We just add the rest of them. So basically, it just be 2,100 times, that's just 11.3 plus 33, 3.33 times 10 to the power 5 plus 4180 times 3.6. Not do that right. It went into the power of 5 plus 4180 times 3.6. And we get 371778 equals, the other one's just numbers. So wait, it'll be 2100 times 11.3 plus 3.33 times 10 to the power 5 plus 410. Okay. Let's do the second half of the equation. So 0.195 times 4180 times 7, take 3.6 plus 0.215 times 840 times 19.7, take 3.6. And that is 16030.77. Use that divide by 371778, and that should get us this. That means m will equal to 0.043.1 kilograms, which means it is 43.1 grams. Oh, that's for this question, and let's move on to the second question, and that says with the last question, that's just the weight, the mass of the ice you need to make the drink cooler. And for the next question, it says a maintenance worker uses steam to defrost a small freezer that contains 1.5 kilograms of ice at 0 degrees. Calculate the mass of the dry steam at 100 degrees Celsius. He needs to convert all the ice to water at 24.5 degrees Celsius. Assume the heat absorbed by the freezer's plastic lining is negligible. Negl negligible. Negligible. Yes, okay. Basically, let's do that again. So this thing only have steam and ice, so everything's just water. So basically, we first have 1.5 kilograms of ice at 0.00 degrees Celsius, which means we'll just take the ice from here. So ice is C equals 2100, latent heat equals 3.33 times 10 to the power 5. And for the and then for the steam the person added, we need to find the mass. So that's that. And it starts from 100 degrees Celsius, like normal steam. And the C of steam is we don't need that actually. We don't need the C because they're already at 0 degrees. We only need the latent heat. My bad. We need that. So we also just don't need C. So L equals just 2.26 times 10 to the power 6. And water, as we know, is 4180, so we don't need to do anything about that. So first, we have to form an equation of this. So basically 1.5, which is the weight, well, times 3.33 times 10 to the power 5. We have to, that's now everything's water. So now we can just do 1.5 times 4180 times, it starts at 0, but it wants to end at 24.5 to the 0. And this will equal to m 2.26 times 10 to the power 6, and now everything's water from steam, plus m 1480 times 100 take 24.5. And let's see what that equals. So 1.5 times 3.33 times 10 to the power 5 plus 1.5 times 4180 times 24.5, which should equal to, yeah, 653,115, not equals, let's do the same thing, 2.26 times 10 to the power 6 plus 4180 times 100 take 24.5. This equals to this big number 2575590 m. And now we can get m equals to this, just have to divide by 653,115. Boo. Wait. Five, 3,115. Oh, we divided the wrong thing. Wait. Divided the wrong thing. So it should be 653,115 divided by the answer. So that will get us the to be 254 grams, kilograms, which means this should be 254 grams of dry steam the person needs to make the ice in his freezer water and on the right temperature. Alright, that's all the questions. Bye bye.